And 4.4a today, we will be talking about angles. So up till now, we have been working with 30, 60, 90, 45, 45-degree angles. Now let's work with angles that are not any one of those. So in 4.4a, we are dealing with non-special triangle angles. Well, let's get started. Let's imagine we had, start here with the first angle. Let's imagine we have an angle here, like so. And we'll start it off with a positive degree. It goes start here. This angle is in the positive, theta's positive, and it gives us the coordinate here. And the coordinates now, remember, we are always are gonna be within maybe not within kind of a circle, but the coordinate they give us is negative 35, negative 12, and they want us to find the sine, cosine, all of the fun stuff using this. Well, here what I can do is I can put it into context of a triangle. All right, I'm going to draw my triangle next to it just so I know what I'm dealing with. I know that the x value is this right here. This is my x value. So this has to be 35. And my up and down then is 12. But negative 35, negative 12, like so. So I can use my Pythagorean theorem to find my hypotenuse. Unless this is a special triangle. Oh, I don't know. So Pythagorean theorem, 12 squared, 144. 35 squared is 1,225 equals c squared plus 144. This is 1,369 equals c squared. C then is the square root of that. And the square root of all of that is 37. Huh, what did you know? The numbers work out nicely. So we can find our sine, cosine, and everything now of that particular angle. And we just put in our little theta is here. We want our theta up at the origin. We're up close to by where the origin is. So now we can list out all the things. Sine of theta is what? Negative 12 over, and in this case, our hypotenuse is always going to be positive. So negative 12 over 37, because sine is so opposite over cosine, adjacent, negative 35 over 37. Tangent is opposite over adjacent, so negative 12 over negative 35. The negatives cancel each other out, so it actually just is 12 over 35. And then the others are the inverses. So I'm just gonna invert my answers here. 37 over 12, negative 37 over 35, and 35 over 12. What if the problem says the point of the terminal side of the position of the angle is the point negative 8, 22? The key word to when we talk about terminal angles, if we ever have any angle, let's say it's down here, the terminal angle is always going to be the angle that is closest to the x-axis. So this will be our terminal angle here. This will be our terminal angle here. This will be our terminal angle here, and then this will be our terminal angle there, just as a point of reference. Let's kind of graph this a little bit, just eyeball it to see what we're working with here. So we got -8 up 22, so probably more like, this is just a figure, it'd be steeper. It would be kind of like this. Let's say this is -8, 22, not in exact points, but we'll just say that is -8, 22. Well, all we have to do now is draw this as our triangle over here, just to give some perspective. I want this angle right there. That is going to be, my angle is always going to be the point of reference when I draw the triangles. So here it is over 8, so this is -8. And this is 22. Well, I want my hypotenuse now, so I'm going to use my Pythagorean theorem. 22 squared plus -8 squared equals c squared. 22 squared gives me 484 plus 64 equals c squared plus 64. This gives me 548. I'm gonna see if that has any 548. I do not know if that has a perfect square in it, but I'm gonna try. I'm gonna divide it by 4. So 548 actually divides by 4. So this 548 divides by 4, which equals 137. So that means, so 137 times 4 equals 548. So c squared equals 2 root 137. I just square root that 4 and keep the 137. It's actually 2 root 37. So here, this is 2 root 137. Now I can find all my other functions. So sine of theta will be 22 divided by 2 root 137, which is 11 over root 137. Cosine of theta is -8 over 2 root 137, reduces to -4 over root 137. Tangent of theta is 22 over -8, so -22/8 reduces to -11/4. And now the opposite, the inverses, are just inverse of everything that we already found. So I'm just going to invert everything else. And there we go. That's how we find that. Let's do some logic theory now. So let's say, I've already brought up before, sine is your y value. Cosine is going to be your x value. So let's say, well, sine is greater than 0, but our cosine is less than 0. Well, let's think about that, what that means. That means our x's are negative and our y's are positive, right? Positive y. So, and they want to find us what quadrant that lands on. Remember, this is quadrant 1, 2, 3, and 4. Well, our x's are negative, so we go down this way, and our y's are positive. It lands in quadrant 2, just like that. If our sines our, let's say our sine are positive and our cosine are positive. They're both greater than 0. If that is, then they're both positive, then go over, over. Well, that's quadrant 1 right there. So knowing that our sine and cosines, cosine correlates to x, sine correlates to y, you can figure out which quadrant the coordinates land on.